Hey guys, Kyle here with ServoCIty. Today I want to talk to you about Actobotics and different ways to run shafting through the channel in a set of bearings. The other day I shot a quick video on different ways to run the shafting through the sides of the channel, so through this way. Today I want to talk to you about different ways to run it through the bottom of the channel and up through the open side. So starting from the top, I have probably the most conventional way to do it. I've grabbed a 1/4 inch D shaft and put a 1/4 inch by 1/2 inch flange bearing into the back side of the channel to run the shaft through, followed by a 1/4 inch shaft spacer and a 1/4 inch set screw collar. So that holds the shaft in place from sliding that direction. On the front side, I grabbed a side tapped bearing mount with a 1/4 inch bearing pressed in. All of the bearing mounts come with the bearings already pressed in, so you don't have to worry about purchasing those separately. And that is followed up by a 1/4 inch Actobotics clamping collar. The clamping collar is nice because it already has a flange built in, so you don't have to worry about the clamping collar contacting the outer race of the bearing. For the second setup, I used a larger shaft. This happens to be a 3/8 inch round shaft running through a set of bearings. So the bearing on the back side, I grabbed a face through hole bearing mount that once again it already has the bearing pressed in, and then that is attached to the channel using a large square screw plate in the interior. So you can run the 632 socket head screws through the bearing mount, through the channel, and into the tapped holes of the screw plate inside. And then following that, I have a 3/8 inch shaft spacer and an aluminum clamping collar. We have clamping collars in both aluminum and steel. Each one would do the job the same. On the front side, I have another one of the side tapped bearing mounts in the 3/8 inch variety this time. It has a 3/8 inch shaft spacer following the bearing mount, and then a 3/8 inch clamping hub in order to hold that shaft in place. I used clamping on both the front and the back side of this shaft, that way there's no marring involved. It doesn't scrape the shaft or anything, so if you ever want to take this apart, you can easily loosen these up, slide them off, and slide the shaft out of the bearings. If you put a set screw down on this shaft and then wanted to take that out of the bearings, it's going to catch where that set screw put a little mark on the shaft. Version 3, I have a 1/4 inch round shaft running through the bearings. This 1/4 inch round shaft is held into place just like the top setup using a 1/4 by 1/2 flanged bearing, and then I have a shaft spacer and then a 1/4 inch clamping hub, that way we don't mar the shaft. Now this setup is a little unconventional, you don't see it that often when using Actobotics, but it's worth noting. The bearing on the inside of the channel is held by a hub spacer, and the hub spacer is bolted in to the back side using 632 by 3/8 inch socket head screws. So the hub spacers all have a 1/2 inch bore, so I grabbed yet another 1/4 inch by 1/2 inch flanged bearing, dropped that into the 1/2 inch bore of the hub spacer this time, and then followed up with an Actobotics clamping collar that has that built-in flange. Setup 4, I have a 1/4 inch D shaft running through the bearings. Now this too is a little bit unconventional. I have a dual ball bearing hub inside. Now the dual ball bearing hub is probably one of my favorite parts in Actobotics, and I like it so much because it has two bearings pressed in, so the bearings are held nice and concentric with one another. You don't have to worry about them being misaligned. All you have to do is bolt that dual ball bearing hub to a surface and run your shaft through it. Now the dual ball bearing hub is held in place using the 632 by 3/8 inch screws running through the back side of the channel, and then on the back side of the shaft I have a 1/4 inch shaft spacer that actually sets down in there to where you really can't see it very well on this, followed by a 1/4 inch set screw collar. Now on the inside I have basically the same setup. I have a shaft spacer up against the interior bearing, and then I have a 1/4 inch set screw collar there as well. One thing worth noting, these two setups are nice and sleek. They keep everything on the interior of the channel to where if you want to mount this down flush to something, it works very well. but the further you have your bearings apart, the more stability you're going to have. So, you know, if you ran a longer hub spacer on version 3, it would definitely be more solid. While this setup is nice and clean and keeps everything inside, it's not going to be quite as solid as one of the top ones. On version 5, I have a 1/4 inch round shaft running through the bearings. This setup is unique because I've used a quad hub spacer on the interior of the channel, and that's to hold the bearing in place. Now, you might ask, why would you grab a quad hub mount and then grab a flange bearing instead of just doing the setup kind of like the first one there? Well, if I was ordering the parts for a specific purpose, yes, I'd probably go with the first version that I showed you. But if you're just digging around in your toolbox of Actobotics parts, or if you're just building up inventory to make all kinds of neat projects, the 1/4 inch flange bearing and the quad hub mount, the 545-360, are probably two of the most commonly used parts in Actobotics. So it gets the job done very well, and it allows you to repurpose those for another project at some other time. So going through that from the back to the front, I've got a 1/4 inch flange bearing, a 1/4 inch Actobotics clamping collar that has the built-in flange, and then on the front I've got a quad hub mount with the 1/4x1/2 flange bearing into the 1/2 inch hole of the quad hub mount, followed by the 1/4 inch shaft spacer and the 1/4 inch clamping hub. For the 6th and final setup, I had to put that on a new piece of channel. Kind of ran out of room there. So I have a 1/4 inch D shaft running through the two bearings, and this too is a little bit unconventional. I've got the same setup on the back that I've used kind of throughout. I've got a 1/4x1/2 flange bearing with a shaft spacer, and then a set screw hub on the D shaft in order to hold that in place. Now the front setup is a little bit different. This very similar to version 5 over here. It's using unconventional parts to get the job done so that you can repurpose them some other time. So I've got a face through hole pellet block or bearing mount on the front here, and that one is attached to the channel using 4 632 round standoffs. Now I have the 7/8 inch standoffs in this assembly. If I had used the 3/4 or anything below that, then you'd be able to put this channel right down on a flat surface and have that shaft rotate without contacting anything below. So you can keep everything nice and flush and clean on the underneath side if you want to mount that in a low profile application. So today I've given you 6 different ways to run shafting through the bottom of the channel and up through the open top. The other day I shot a video on different ways to run the shafting through the sides of the channel. Now there are a lot of concepts on this video that you might want to look into, such as how to run 1/8 inch shaft instead of 1/4 inch shaft. I know I used a lot of the 1/4 inch shaft on the assemblies today, or how to run the bearings on the interior of the channel instead of the exterior of the channel if you want to make a little bit sleeker and cleaner looking setup. So you can apply these same concepts that I talked about in the prior video into this style assembly here if you want to.